Hi, how are you doing? This is AWS By Doing. I'm Madhu Vasudevan from the AWS By Doing team. Welcome to this educational video series, AWS By Doing, wherein you can learn AWS Cloud Computing by following along with an AWS Certified Solutions Architect. We acknowledge and thank the official AWS documentation material which we have used to produce this educational video. Although we would try to keep all resources consumed eligible for the free tier, ensuring that you are not charged or minimizing your charges is your responsibility. To minimize charges, remember to delete all created chargeable resources after each session. This time, we will walk you through a hands-on lab on create an empty VPC using the Amazon VPC console, create an internet gateway and attach it to your VPC, add a subnet to your VPC, create a custom route table and make the subnet public, create a custom network ACL and associate it with the subnet, create a custom security group to allow SSH and HTTP access, launch an EC2 Linux instance into your subnet, allocate an elastic IP address and assign it to the instance, SSH into the instance and install Apache, access the instance over HTTP, and finally delete all created resources. The estimated cost for doing this hands-on is no charge, as EC2 instance with elastic IP attached is free tier eligible. The prerequisite AWS skill level required is that of a beginner with general understanding of AWS VPC and EC2 concepts. To set up a free tier eligible AWS account and a user with sufficient permissions, check out our video on Create Admin User. To begin, fire up a browser, preferably Google Chrome, and head to aws.amazon.com. Sign in to the AWS Management Console as a user with administrator credentials. This is what we will create in this hands-on session. To create a VPC using the console, open the Amazon VPC console. From the region drop-down, select the region closest to you for best performance. In the navigation pane, choose your VPCs. Click on Create VPC. Specify the following VPC details as needed. Name tag. Optionally provide a name for your VPC. Doing so creates a tag with a key of name and the value that you specify. IPv4 CIDR block. Specify an IPv4 CIDR block for the VPC. We recommend that you specify a CIDR block from the private, that is non-publicly routable IP address ranges as specified in RFC 1918. For example, 192.168.0.0/16 or 10.0.0.0/16. IPv6 CIDR block is optional. To associate an IPv6 CIDR block with your VPC, choose one of the following options. IPv6 CIDR owned by me is Bring Your Own IP, allocates an IPv6 CIDR block from your IPv6 address pool if you have any. For pool, choose the IPv6 address pool from which to allocate the IPv6 CIDR block if you have any. Or else, choose the Amazon provided IPv6 CIDR block. This requests an IPv6 CIDR block from Amazon's pool of IPv6 addresses. For tenancy, select a tenancy option. Dedicated tenancy ensures that your instances run on single tenant hardware. Leave it at default and click on Create. Your VPC is created. Click Close. This is what we are trying to create. To create an internet gateway and attach it to your VPC, open the Amazon VPC console. In the navigation pane, choose Internet Gateways and then choose Create Internet Gateway. Optionally, name your Internet Gateway. Tags are optional too. Choose Add Tag. Key a value. Enter the key name. For value, enter the key value. Choose Create Internet Gateway. Next, click on Actions, drop down, click on Attach to VPC, select your VPC from the list, and then choose Attach Internet Gateway. This is what we are trying to accomplish. To add a subnet to your VPC, open the Amazon VPC console. In the navigation pane, choose Subnets and then Create Subnet. Specify the subnet details as needed. Name tag optionally provides a name for your subnet. Doing so creates a tag with the key of name and the value that you specify. For VPC, choose the VPC for which you are creating the subnet. For availability zone, optionally, choose an availability zone or local zone in which your subnet will reside, or leave the default no preference to let AWS choose an availability zone for you. Choose availability zone A. IPv4 CIDR block. Specify an IPv4 CIDR block for your subnet. For example, 10.0.0.0/24. For IPv6 CIDR block, which is optional, if you have associated an IPv6 CIDR block with your VPC, choose Specify a custom IPv6 CIDR. Specify the hexadecimal pair value for the subnet. Click on Create. Your subnet is created. Click Close. This is where we are headed. To create a custom route table, open the Amazon VPC console. In the navigation pane, choose Route Tables. And then choose Create Route Table. In the Create Route Table dialog box, optionally name your route table. Then select your VPC from the drop-down. You could optionally add tags and then click on Create. You have created your custom route table. Click on Close. Select the custom route table that you just created. The Details pane displays tabs for working with its routes, associations, and route propagation. On the Routes tab, choose Edit Routes, Add Route, and add the following routes as necessary. Choose Save when you're done. For IPv4 traffic, specify 0.0.0.0/0 in the destination box. And select the Internet Gateway ID in the target list. For IPv6 traffic, specify ::/0 in the destination box. And select the Internet Gateway ID in the target list. Click on Save Routes. Click on Close. On the Subnet Associations tab, choose Edit Subnet Associations. Select the Associate checkbox for the subnet 1 and then choose Save. You have associated your subnet with your custom route table. This is what we are trying to accomplish. To create a network ACL, open the Amazon VPC console. In the navigation pane, choose Network ACLs. In the Create Network ACL, dialog box, optionally name your network ACL. And select the ID of your VPC from the VPC list. Click on Create. Your network ACL is created. To add rules to a network ACL, open the Amazon VPC console. In the navigation pane, under Security, choose Network ACL. Select your network ACL. In the Details pane, choose Inbound Rules or Outbound Rules, depending on the type of rule that you need to add. And then click Edit. In rule number, enter a rule number, like for example 100. The rule number must not already be in use in the network ACL. AWS processes the rules in order, starting with the lowest number. We recommend that you leave gaps between rule numbers, such as 100, 110, 120, rather than using sequential numbers like 101, 102, 103. This makes it easier to add a new rule without having to renumber the existing rules. Select a rule from the type list. For example, to add a rule for HTTP, choose HTTP. To add a rule to allow all TCP traffic, choose All TCP. For some of these options, for example HTTP, AWS fills in the port for you. To use a protocol that's not listed, choose Custom Protocol Rule. If you are creating a custom protocol rule, select the protocol's number and name from the protocol list. If the protocol you selected requires a port number, enter the port number or port range separated by a hyphen. In the source or destination field, depending on whether this is inbound or outbound rule, enter the CIDR range that rule applies to. From the Allow Deny list, select Allow to allow the specified traffic or Deny to deny the specified traffic. To add another rule, choose Add Rule and repeat the steps as required. And when you're all done, click on Save. These are the inbound rules we need for our network ACL. To accommodate IPv6, add another rule for each of these to allow for the IPv6. Under the source, you should specify ::/0. This is how a port range is added. When you're done keying in all the inbound rules, click on Save. These are the outbound rules we need to add for our network ACL. Click on Edit Outbound Rules and add rules. Having added rules for HTTP and HTTPS, outbound IPv4 and IPv6, this is how you add a rule that allows outbound IPv4 and IPv6 responses to clients on the internet for ephemeral ports. For example, serving web pages to people visiting the web servers in the subnet. Click on Save when you have keyed in all the outbound rules for your network ACL. To create a security group using the console, open the Amazon VPC console. In the navigation pane, choose Security Groups. Choose Create Security Group. Enter a name for the security group and then provide a description. From VPC, select the ID of your VPC. Scroll all the way down. You could add tags. This is optional. With the default inbound and outbound rules, click on Create Security Group. To add, edit, or delete rules for your security group, open the Amazon VPC console. In the navigation pane, choose Security Group. Select the security group to update. Choose Actions. Edit inbound or outbound rules. Click on Edit Inbound Rules and choose Add Rule. For type, select the traffic type. And then specify the source for inbound rules or destination for outbound rules. For a public web server, choose HTTP or HTTPS and specify a value for source as 0.0.0.0/0. If you use this, you enable all IPv4 addresses to access your instance using HTTP or HTTPS as per the type. To restrict access, enter a specific IP address or range of addresses. You can also allow communication between all instances that are associated with this security group. Create an inbound rule with the following options. For source, enter the ID of the security group. Choose Save Rules when done. These are the inbound rules that we need to add to our security group. When done adding the inbound rules, click on Save Rules. For outbound rules, we will allow all outbound traffic from our security group as per the default. Thus, we have added the requisite inbound and outbound rules for our newly created security group. This is what we are trying to accomplish. Next, we need to create our EC2 instance, but before that, we need to create a key pair that would allow us to log in or SSH into our new EC2 instance. To create your key pair, open the Amazon EC2 console. In the navigation pane, under Network and Security, choose Key Pairs. Choose Create Key Pair. For name, enter a descriptive name for the key pair. Amazon EC2 associates the public key with the name that you specify as the key name. A key name can include up to 255 ASCII characters. It can't include leading or trailing spaces. For file format, choose the format in which to save the private key. To save the private key in a format that can be used with OpenSSH, choose PEM. To save the private key in a format that can be used with PuTTY, choose PPK. We'll go with PEM, and then you could add tags. Key in a name, since key pairs are region specific, and click on Create Key Pair. The private key file is automatically downloaded by your browser. The base file name is the name you specified as the name of your key pair, and the file name extension is determined by the file format you chose. Save the private key file in a safe place. This is the only chance for you to save the private key file. To launch an EC2 instance into a VPC, open the Amazon EC2 console In the navigation bar on the top right, ensure that you select the same region in which you created your VPC. From the dashboard, choose Launch Instance. On the first page of the wizard, choose the AMI that you want to use. For this exercise, let's choose the default. On the Choose an Instance Type page, you can select the hardware configuration and size of the instance to launch. Let's go with the default free tier eligible T2 Micro and click on Next, Configure Instance Details. On the Configure Instance Details page, select the VPC that you created from the network list. And the subnet from the subnet list. Leave the rest of the default settings and go through all the next pages of the wizard until you get to the Add Tags page. On the Add Tags page, you can tag your instance with a name tag, for example, My Web Server. This helps you to identify your instance in the Amazon EC2 console after you have launched it. Configure the security group when you're done. On the Configure Security Group page, the wizard automatically defines the Launch Wizard -number security group to allow you to connect to your instance. Choose the security group that you previously created from Select an existing security group. Click Review and Launch. On the Review and Launch page, choose Launch. In the Select an existing key pair or create a new key pair dialog box, you can choose an existing key pair or create a new one. If you create a new key pair, ensure that you download the file and store it in a secure location. You'll need the contents of the private key to connect to your instance after it's launched. To launch your instance, select the Acknowledgement checkbox and then choose Launch Instance. On the confirmation page, choose View Instances to view your instance on the Instances page. Select the instance and view its details in the Description tab. The Private IPs field displays the private IP address that's assigned to your instance from the range of IP addresses in your subnet. Note that no public IPs has been assigned to the instance. That is the default for newly created custom subnets unless you specifically enable that feature in the newly created subnet. To allocate an elastic IP address for use in a VPC, open the Amazon VPC console. In the navigation pane, choose Elastic IP. Choose Allocate New Address or Allocate Elastic IP Address. Specify the Elastic IP address if you are bringing in your own IP, or else go with the default and click on Allocate. You could tag it to identify it. To associate an Elastic IP address with a running instance in a VPC, select the Elastic IP address that's allocated for use with a VPC, and under Actions, click on Associate Elastic IP Address. Choose Instance or Network Interface and then select either the Instance or Network Interface ID. Select the private IP address with which to associate the Elastic IP address. And click on Associate. Go to the EC2 console and verify that the new Elastic IP has been attached to your EC2 instance. We are good. Next, we will connect to our instance using SSH. In a terminal window, use the SSH command to connect to the instance. You specify the path and the file name of the private key, the .pem file, the user name for your instance, which is EC2-user, and the public DNS name for the IPv4 address for your instance. To connect your instance, use the following command, or you could just connect from the Connect tab. To connect via SSH, copy the command shown. To connect to your instance, bring up the Windows PowerShell or the SSH terminal. When you see a response like the following, just enter yes. You have successfully accessed the instance via SSH. Next, we'll install Apache on the EC2 instance. These are the commands to install Apache on the EC2 instance and also verify I have listed these commands in the description in case you want to copy and paste. Just customizing it a little bit. In a browser window, key in the Elastic public IP attached to the instance to access the instance via HTTP. You have successfully accessed the instance via HTTP. Congratulations! This is what we have accomplished, what we had set out to accomplish and what we have finally accomplished. So congratulations. And now it is cleanup time. Before you can delete a VPC, you must terminate any instance that are running in the VPC. You can then delete the VPC and its components using the VPC console. So first to terminate your instance and then release your Elastic IP address and finally delete your VPC, let's go to the Amazon EC2 console. Open the Amazon EC2 console. In the navigation pane, choose Instances. Select the instance. Choose Actions. Then Instance State. And then select Terminate. In the dialog box, expand the Release Attached Elastic IPs section and select the checkbox next to the Elastic IP address. And choose Yes, Terminate. Wait until the instance state shows terminated and then go to the Amazon VPC console. In the navigation pane, choose Your VPCs. Select the VPC you wish to delete. Choose Actions. And then choose Delete VPC. When prompted for confirmation, choose Delete VPC. You have deleted the VPC and all related resources. Well done. Thanks for watching. Please give a thumbs up to this video to encourage us. Share this video with your friends and colleagues. Also, subscribe to this channel AWS By Doing, and we will update you regularly with our latest and greatest offerings. Write in a comment of what you liked and how we can improve. Happy cloud computing, and we will see you again in the next episode from the AWS By Doing team.